Okay, the recording is on. We all have a sense of what is going to happen. Those who just arrived, warm welcome. Great to have you here. Please use the chat for introductions. Let us know about yourself, your name, affiliation, and brought you here. And I pass it on to Julio, please.
All right. Hello, Ella. Hello, everyone. I see so many nice familiar faces from the space. I'm very happy that we're doing this for the first time together in an online space to talk about autonomous teas, trustless teas. It's called in different ways. I'll try not to take too much time. Maybe by way of introduction, I'll also introduce myself. I am an economic anthropologist, actually. And I would like to maybe tell you a bit of the story of how I got to this topic, so that we can, get started with everyone else's talks and go through the day today. So we actually were working with a lot of the people at Poetic on a project that was very utopian. It was called Circles UBI, and it wanted to give everyone on Earth a universal basic income. And we made the system. We piloted it for many years in Berlin. It's now live on Gnosis Chain. Actually, we have our 4th anniversary tomorrow. And one of the main questions that we had with the making of Circles is how can we actually anonymize the relationships, the payments, the trust that happens within this network? Because today everything is transparent on chain. And so through this sort of rabbit hole of how to make Circles into a privacy preserving system, we ended up in the realm of TEs, particularly by connecting with Andrew Miller, who I'm sure many of you know him and have worked with him. And at the time, of course, we thought, okay, TEs are great, but they have many problems. And so I did a bit of research and a bit of ethnography, let's say, about the state of TEs and chip production in general. And in order to create a vision that is still, of course, in a process of being created, but we released on EthCC a manifesto that we call the Autonomous TE Manifesto, which was a beginning trying to tease out what would it mean to make an open, trustless, verifiable, a trusted execution environment. Now, this is, of course, a large question. Like to make a chip, you need at least 200 people, and it is something that in no way can a small startup like Poetic take on by themselves. So we thought, okay, how could we self-organize in a decentralized way with all the different people doing work on TEs that have a common sort of a goal, have a common mission, so that we can get into that direction. And so we started doing research into this, and we came across the work of Sylvain, who will be presenting shortly. And he's been banging on the drum, I have to say, of what he calls QTs, or quantum-based TEs, which I think is very lovely because it's really trying to push the technical imagination of what is possible today. How can we move beyond what we currently have, SGX, TDX, you name them, and how to do that collectively as a space within the crypto world, and also to connect the different communities, such as the open hardware community, but also the crypto world. So with that, we started talking to people, different universities and research institutes, particularly Simple Crypto, which is an initiative that was born out of researchers in UC Louvain. And they are world experts at open hardware and tamper-resistant hardware. And in the Autonomous TE Manifesto, we talk about physical and clonable functions, about proofs, which are effectively a way to create a fingerprint, a signature that cannot be tampered with because it actually leverages the randomness of matter in the chip in order for it to be generated. So when we spoke to the Simple Crypto folks, they said, okay, we can actually build a proof signature oracle in a period of about 3 years, to set the basis of what would be a fully fledged autonomous TE. And so we were talking to them and also people at IC3 in the US and other places to try to connect the academic world with the industry, also with capital, with investment, so that we can set up a roadmap that leverages both academia and business as a way to actually get there. So of course, this is in no way a mission that Poetic can do by themselves. The Poetic Technologies actual focus is actually on binary security. So our focus is on reproducible builds, and this is what we work towards. We're making at the moment, we call it a Poetic T build system that gives you an operating system image for SGX and TDX as a replacement for Grameen. I'm sure many of you here know what Grameen is, so I don't need to explain this to you. But because we see that, at the low level of binaries is something people don't think about, but also at the level of hardware, if you're serious about creating a decentralized world, having the ability to compute over private inputs in such a way where we know that attestations are not being forged, and that there are proofs of manufacturing in the actual hardware, in such a way that it actually decentralizes the knowledge over chip production, which is, I would argue, an existential threat for all of humanity, then I think we can actually do some interesting things. So to summarize, we went from a very utopian project, a universal basic income for all of humanity, to now trying to make open source TE. And so we were successful with making circles a reality for a few people here in Berlin. The project continues now with the guidance of Gnosis. And today we are very excited to come together and start to plant a seed and see where that seed can lead us. So yeah, thank you very much. Today we will have many nice talks by many very, very, very great projects to sort of give you a sense of, first and foremost, who is there in the space and what are each person doing, right? I think we can complement each other in terms of the different domains of knowledge that we do, right? To make a fully fledged open source TE from the hardware to the software, we require a plethora of different teams. And so this is what we're trying to put together in the spirit of decentralization. So welcome, everyone. I am Julio, the CEO of Poetic Technologies, and I hope we have a lovely hour and a few minutes left.
Thank you so much, Julio, and hi, those who just arrived. Welcome. I'm Ela, one of the founders of Poetic, and I'm going to moderate today's session. And yeah, we just had an introduction by Julio, and I think this brings us straight into the overview of the TE network, of the current TE network. And Julio, I wanted to ask you, because you also planned to give a brief intro. Was that the intro we already had, or that was it already? That's great, because that makes a little bit more space and time for everyone else. So I would love to ask Sylvain if you are already here. Sylvain, are you here to give us? No,
I think he's having connection issues. I think he'll be here shortly. Yeah.
Okay, this is absolutely no problem, because then we might just move on. And I would like to invite Shelvan Su. You are here already. Hi, from Fala Network. Great to have you here, Shelvan. And the stage is yours, and I kindly ask you to maybe speak for around 5 to 7 minutes max, so that we have enough time for everyone. Warm welcome to Shelvan, please.
Sure. Yeah, may I share my screen? Okay.
Does it work for you?
Yeah, I think.
Yeah, fantastic.
A second. Yeah. Okay. Can I see my screen now?
We
Okay,
can.
cool. Yeah, cool. So yeah, hello everyone. Yeah, it's great to be here. I'm Shelvan from File Network. Oh, yeah. So yeah, so I think today I will just give a brief introduction on the File Network and what we are doing recently, and also it's very good to learn what everyone else is doing right now. So Fala is created from 2019. And at the first day of our beginning, actually, what we try to achieve here is to build a real decentralized TE network. I mean, like every node in the network should be TE hardware, and every node should be come from the not from us, but from our community. So also we want all these TE hardware to be managed by the blockchain. So this is how the story begins. And until now, actually now we have over 30K TE nodes in our network. And this means actually now we are managed, actually all of them are SGX, and now we are adding support for multi hardwares. And now we are managing the world largest decentralized TE network, which is really like, you can see its skeletons across all over the world. Yeah. And I think the core problem we have been realizing here is that although T is useful regarding its like performance and also like the implementation cost, but T is not trusted. And actually, the root of the problem here is that it's about what's the root of trust of TE. And currently, it's this. I think this established for Intel SGX, Intel TDX, and also AMD SDV. Actually, all these the current T implementation is depends on some secret keys, which is generated and stored in the hardware during the manufacturing. So this is the current root of trust, because this key is then used to derive all these keys to like steal the T data and also like to use to sign the I report. So, but this is the problem, because actually now you can see the risk that this root of trust can be, I would say, cracked. And I think this problem is even more important than the others vulnerabilities about TE, because the others vulnerabilities, they can be patched with some upgrades, maybe in the firmware, in the microcode, and in the BIOS. But once a TE secret key is leaked, then this means this TE hardware cannot be used anymore, because the attackers can just fake these hardwares using the leaked secret keys. So this is a problem. And also this leads to the other problem, like the lack of service availability promise in TE. So this is what we want to do, is that we try to replace the current hardware-based root of trust with a decentralized root of trust, which is on-chain and which is totally managed on-chain. So it actually is a hybrid system combining the smart contract and also the off-chain TE workers. So what we built now is, first we have built the decentralized root of trust, which is totally governed by the on-chain console, and also it consists of multiple nodes. Now they share the same secret keys as the master key. We call them a gatekeeper. So they're currently the TE hardware with the higher security level, and now we are trying to update it to the MPC solution. So combining the MPC and TE, so actually we do not need to, I think the security level will be even better. So the second thing here we implement is that we have built the chain of trust, which is a key management system using the key derivation function. So based on this root key. So, and now we support upgradable applications, and also we support different hardware. So now we support Intel SGX, Intel TDX, AMD SEV, and also TE GPU. And also I think when the autonomous TE is available, we are very glad to be the first for that as well. Yeah. So the third part is that we have implemented a co-processor solution. So we allow the smart contracts, only if they are on an EVM compatible chain, we can allow them to offload some part of their computation to our TE workers. Yeah. Yeah, I'll quickly script this part. So because yeah, actually in our model we just not solely trust TE hardware, so we use on-chain smart contract to govern them. And also, since the key management is standalone, it's outside TE, which means actually we support the migration for the application on different TE hardwares. So our key management service it determines like which TE hardware application can run on. So this means even if one TE hardware is down, we can safely like migrate the application to another ones. Okay, so there is already many security research on Fala. So I would say like Fala is now one of the T network of the top security promise. Because until now, from 2019 to until now, so there is many accidents about TE. So Fala survived all of them, and also based on the security research, Fala is one of the best TE network of the top security promise. Yeah. So now things now we are beginning to support multi-hardware. So a very important direction here is that we are supporting TE GPU. So and also we are supporting the AI model training on TE GPU. So this will be a very important use case for us to do now. Yeah. So also another things which we are doing right now is to build a TE SDK to simplify developers' cost to deploy the application to our network, to all the TE network actually. So because we think the Intel TDX is the real game changer here, because compared with SGX, the TDX totally removed the needs for you to change the code. So and what's our job is to make these things I think even more easier, because like so TDX or although it didn't require like you to change the code, I think many developers they didn't understand TE. So we want to abstract out more details. So they do not need to know how to set up TE. They do not know all the security best practice for it. So our SDK should take everything for them. And this is a cooperation between Fala and Flashbox. So Flashbox has proposed the SDK called DStack. And I think now Fala is becoming the major contributor to it. So I think the good part for it is that it's not limited to the hardware on us. So no matter like what kind of hardware, only if it's a TE and it's support TE primitives, I think there's a chance for the SDK to support that. So I think this will be a thing that benefits all the community. Yeah. So this is some recent work we have proposed. Like we have run the first performance benchmark on the TE GPU. So, and I think the result is very promising, because we can see that actually in the default setup of the current AI model, you can see that the overhead of TE is very low, and it can even be just ignored. So I think this will be a very promising work, no matter for the TDX and also for the TE GPU. Yeah. Yeah. I think, yeah, that should be all from me. So I'm also very glad to hear the progress for the other team. Thanks.
Wow, amazing. Thank you so much, Shelvan. And I want to encourage everybody who has questions for Shelvan, please use the chat. You can send your messages there, and you can collect them. And I'm sure Shelvan is gladly answering.
Sure, yeah.
Thank you so much. Cool. So I just spotted Sylvain coming in the room, but let's give Sylvain a couple of minutes to arrive. I don't want to rush you into the presentation just now, Sylvain. Welcome. But I would be super happy to invite our next speaker, and that is Tanmay Gul from GMMS Labs. Are you still there?
Hello. Hey, everyone. Yep.
Yeah, amazing. So very welcome. Do you have any slides?
No, I don't have any slides, but I would like to talk about it. First of all, I'm very glad for the initiative that that Poetic Technologies has taken, and it is very admirable to take on such a task in such a complex industry as hardware. And there is a specific need for it as well, in my opinion, because a lot of the security primitives that we use today are derived from these TTs that are developed by closed source companies. And the root of trust in which almost all of the world places their trust in financial transactions, their personal data, all of this is very vulnerable to being exploited by just slightest attacks. So yeah, and just a bit of introduction for me. So I have a background in hardware architecture. I've been researching and developing computer architecture and doing studies around performance architecture, doing security analysis attacks, and just mainly looking at characteristics of what computer architecture is on a granular level. And close to 5 years, I was working at NVIDIA for the like up until July of this year, and so it's great to hear about like the open source community take into their hands uh, this challenge, which has generally been tackled by like the very big giants of the hardware industry. And I would take this opportunity to provide some perspective on how the companies that execute these things today approach these problems. So within the ecosystem of closed source companies that are developing these solutions, I think it is very important to note that it's not the fact that it's they are malicious in intent from the nature, but the economic forces that drive innovation for such setups is that they only tend to focus on attacks which can be proven to be deployed. So internally, a lot of these companies, what they do is that they try to analyze their threat models and see what kind of attacks are deployable on a large scale, which can affect a huge user base or like large customers. But that approach has problems in like what multiple open source works have pointed out is that they tend to exclude some things which are not as pressing as at that scale, but still, nevertheless, those are important. Like for example, they don't include like robust security for side channel attacks. They don't implicate that these chips are going to be secure from any kind of physical attacks. So these incentives are what we are trying to focus on. And the overall challenge, I feel like, is very huge. And what we should try, the focus should be on becoming a value add in the industry. So a lot of the open source talk that I've seen about these is that we need to derive trust from verifiable compute. We need to implement technologies which can be verified from end to end. And although that, in my opinion, is an achievable goal, but what we need to figure out is that how to take some steps towards this direction. So, uh, like building tooling regarding open source technologies, like what Selen presented in terms of using the existing hardware and building primitives around it, which can derive trust other than the root of trust that these companies have designed. That is very important. And also, like it is also important to understand that these are just not a source of secured keys storage, right? Or it is just not an attestation machine. The concept of these can be used heavily in other industries also, like identification systems. It can be used to like verify compute, which is now being explored. So the opportunity that the big companies are leaving on the table because they are focusing on their economic incentives gives us a very strong, a very large playing field in terms of what is actually doable today. And I think the work is moving in that direction. Um, I would also like to introduce a little bit about the project that I'm working on with my team right now as well. So what we're trying to do is that one of the applications that we realized of that can come with secure computation is that the telecommunication networks or the communication that you do with other people, be it internet or normal telecommunication networks, those also involve personal data exchange. Those also need privacy and security. And what we're trying to build is that we're trying to build a security system that lives on your device, leverages the separate coprocessor on your devices, which is called EYCC module. Uh, Leverages that to create a decentralized identity, to use that as as root of trust with the ZKPs to secure your identity and your data over telecommunication networks. So yeah, that's what we're trying to do. And again, I very happy for the opportunity to talk. And yeah, great initiative with Poetic Intents. I would love to hear how I would love to explore how this space goes on forward.
Amazing. Thank you so much, Tanmay. It was great to have your input, and we do have a session coming up after this one where we all have a chance to chat a little bit among each other, and yeah, to really find out how we can collaborate. So this is also just the start. Today's meeting. It's hopefully not the last opportunity for us to get together and to strategize. If you have any questions for Tanmay, please go ahead and use the chat, and let's collect all your comments and questions there. And now I would like to welcome Sylvain Belmar. Sylvain, I know that you are with us now, and hopefully you could arrive and get a little bit of the vibes of this call. Very welcome, and I would kindly ask you to take it over for a brief introduction about yourself and your work, please.
Hi, yeah, hi. Sorry for being late. I had my calendar entry was showing that it was in 2 hours from now. Okay, thanks for taking the time to join this call. I've missed, I don't know what was discussed a bit like at the beginning, but so maybe what I can present. So I'm a research engineer with IC3 for the past 6 years. IC3 is means Initiative for Cryptocurrencies and Contracts. It's a consortium of universities headquartered at Cornell Tech, New York. Okay, so, and for the past 4 years, we've been working a lot with Intel SGX mainly, but this is in the context of blockchain protocols. So a lot of people here are familiar with that. So Secret Network, Oasis Network, Fala Network, and there's so various protocols that make use of trusted hardware to provide some kind of security guarantees, right? So, and the main idea is, right, you can send your computation to a node and in this network, and the node will guarantee you that it's going to execute the computation as you expect, and including processing confidential data. So, and in the context of working with this Intel SGX especially, it became clear to me quite quickly that there's an issue with the root of trust, right? So depending on what your trust assumptions are, you have this situation that you have to be extremely careful that you don't want the node operator to attack their own hardware to gain some benefit on the system you're working, that they're participating in it. So to give maybe the easiest example for this is multiple years ago, I think around 2016, people thought, I think it was a project by Intel and IBM called POET, Proof of Elapsed Time. And they thought they would replace proof of work by using a T. And the idea is that rather than try to brute force the hash, they would just wait an arbitrary amount of time. And that arbitrary amount of time was enclave, right? A software program that was run in the secure enclave. So the trust assumption here was that, yeah, the miner here would be able to provide you a proof via attestation that it ran the code that you expect. That means that it did wait an arbitrary amount of time and it was lucky enough to win this little lottery, and then therefore it could get the block reward. But they realized very quickly the problem with that is that people now were incentivized to break into their own hardware. And so this was put aside as and was seen as something that could not be used because therefore there were limits to TEs in the cryptocurrency sort of application context because the amount of money that was available if you attack the system was too high. So consider that for a moment, right? So we have this problem that unlike with mathematics, like zero knowledge proofs, MPC and FHE and so on, where we have some security guarantees that you would have to break the mathematics to break the system. Here we have this more like sort of like blurry or somewhat uncertain situation where it's not clear, right? Depending what kind of equipment you have access to, depending on your expertise, you may be, and if you have physical access to the device, right, you may be able to break it. And so Intel SGX and some of the other systems, the way they are designed, they don't assume like these sophisticated attackers, first of all. They assume like someone who has like limited expertise and limited equipment. So basically a bit like a hobbyist. Like some of us are the same with our phones, unless you're an expert and have the laboratory, you're not going to be able to hack into your phone at the hardware level. So this creates this big problem because, like, again, the money aspect here of blockchain ecosystems is such that the incentives may be really sufficient for people to really try to attack these chips. So that's the angle I've approached the TEs. And this led now to, if I fast forward, to now, there's actually 20 plus years of research that is not leveraged right now with the current TEs that we're kind of stuck with. By the way, right? Yeah. So, okay. So if people have any question, you can stop me, right? Because I don't have like a sort of like, I could present some slides that are from this summer, but some people have already seen that in this talk. So, and it's not going to be, maybe that useful. So we're in this situation right now in the blockchain ecosystem that we don't have anything better than SGX and TDX and AMD. And we're kind of like, people do like very smart work to work around these limitations. However, it makes sense to ask the questions, can we do better, right? And this is where it gets a bit complicated because we have now to really dive deep into how hardware is manufactured, how hardware is designed, and looked at what are the solutions that are better that we could use. But there are multiple solutions that would be better. And again, okay, so we have this problem too that hardware cycles to manufacture hardware is much longer than software. So a lot of people, and I think that's what has happened in the past few years, people are reluctant to go in that direction because you won't get any return or benefit within, a couple of years. Yeah. So I don't know if that's clear as a sort of like setup, right? But to reiterate, right? So we have this problem that, right, trusted hardware depends on this root of trust. The root of trust right now with Intel SGX, TDX, and so on is such that it cannot be, it's not protected, it's not secure against physical attackers. So the best solution to that for now is that people, either their protocol is, there's not much money involved, or not, the incentives to break the hardware is not there, which creates a very difficult situation because we don't even have an economic model for that, so that we can have like some kind of mechanism design or game theory to really design systems properly. The other option is that people rely on cloud infrastructure, and then you expect the cloud provider to protect the hardware against physical attacks. So that's the situation we're at. Now, if we look at, again, there's a Torben who's in this call right now, who's with UC Louvain and Simple Crypto. So there are like groups already that are working on open source hardware, on hardware that is secure against physical attacks. So I think the idea here is that the Web3 community, the blockchain communities need to, there needs to be some kind of synergy that is stronger with the hardware research world and industry so that we can work together to develop chips that are more adapted to what we really need in terms of security guarantees. I would like, maybe it would be more useful if people can ask questions here, so it's more interactive, unless I just pull up some slides or some document, because I prefer like that. It's really, yeah, does it make sense?
It makes Julio, please.
Yeah. Maybe just one prompt for you, Sylvain, is what are QTs?
Well, in the process of looking at this, I just like, okay, because we're the problem here, there's multiple angles to that, like, but one angle is like in theory or in right, because we're in this blockchain context, right? So on one hand, you have all this mathematics that provides us really super high security guarantees as to whether a protocol is going to be secure or not. And then we are using these T's in conjunction or as an alternative to some of, or people combine, okay, with the mathematics-based cryptography. And with T's, it's a bit more difficult to know whether it can be really secure or not. And the idea of QTs was that to ask the question, okay, can we have a model so that we know what are the physical limitations of T's in terms of whether they can be attacked or not? And as far as I understand right now, it's like truly secure T's that are secure against physical attacks, like if you apply this some kind of same mental rigor that we applied to cryptography, it's just not possible. You cannot have a proof, okay, unless you go to quantum device. So the Q and T was a bit to point that we maybe at some point we'll have to use quantum devices for having the same sort of like high security that we want to have. But there's a bit in between that. Before that, what you can do, you can leverage, if I'm talking about now the core problem, right, that you don't, okay, because I want to be careful, because the way when we approach this, it can look very like far-fetched, okay, but it's not so far-fetched. But if you approach it like, because if we try to explain this in simple ways, but again, right, you have a physical device, and the problem is that there's a hardware key that is embedded in that hardware device, and you want that hardware device to be in the hand of someone you don't trust and not be able to extract that private key. So this creates this really difficult situation that, like, how do you do that? That means, because if you're able to write the key, why couldn't you read it? All right. So we need somehow to be able to have a key embedded in a physical device, in a hardware device, that needs to be generated such that no one knows what this key is. And once the key is in the device, no one is capable to extract it, no matter how much money they have and how much expertise they have and how much physical equipment they have, and no matter how sophisticated they are. So again, right, I think in theory you have to go to quantum physics for that. But if in practice, like, we have this thing called physical unclonable functions, which is like, at least in practice, is the best thing that we have and can provide us like extremely high security guarantees that the device will be secure against such attacks.
Sylvain,
yeah.
I hate to interrupt you.
No, it's fine.
Thank you so much for all the insights you have given us. And I'm sure there are many questions that people have, comments, feedback. Yeah. I suggest let's once again collect everything in the chat, because I'm afraid we don't have any time to dig deeper into that right now. And
sure.
Also, we have, last but not least, Zed coming up from Automata Network. And I really don't want to miss the chance to also give you the digital stage, Zed. It would be fantastic, because we are lagging a little bit behind, if you could keep it short and crisp. And I want to hand it over to you. Thank you.
Thanks, Ella. So I'll just make it really short and sweet. So just now, I think, who was it? Tanwei mentioned about EUICC. This is actually an example of it. I'm not sure if you can see it. It's actually a EUICC in a nano-SIM form factor. So it's a kind of like programmable eSIM, but this is in a physical form factor. So you can use it on any phone that supports a nano SIM. So this is the actual kind of like thing that is so they actually this particular chip is actually removed from an iPhone. They removed the EUICC module from the iPhone and they embed it into a nano SIM form factor, so you can actually program it with an eSIM that you register. So just an example. So that aside, there are kind of like, I think, two main points that I want to talk about. The first one is actually on the security of TEs and how we hear a lot of things about how TEs are like not safe, easily broken, secrets are not trusted, etc., etc., etc. But the thing is, I would actually make the argument that it's the same for anything that we as humans engineer or build or program, which includes the so-called math, like cryptographic primitives that we actually invent. Well, the you might actually have certain guarantees or certain proofs about certain cryptographic primitives that is designed, but ultimately you don't operate on that kind of like abstract level. So there's a level of engineering that is involved where we actually convert that kind of like idea, mathematical objects into actual like code that we use in our day-to-day life that our machines can actually execute on behalf of us. And you'll realize that from like 30 years ago up to now, that this is the main source of exploits actually, like those millions and billions of dollars worth of exploits is actually on bugs that that engineers, developers write into the code. So if we think about it that way, I'm a believer of we don't live in a perfect world. We would strive to make things better. That's why I kind of like, I agree with what Sylvan says on like how we should actually think of and identify all the ways how we can make like the kind of like the fundamental, at least the theoretic level of guarantees that we can have as high and as secure as possible. But other than that, we have a set of like standard operating procedures where we can use to help mitigate away a lot of this kind of attacks or vulnerabilities. Like there is going to be bug. In the case of a bug or vulnerability, how can we actually mitigate that? In the case where, let's say, a root key is leaked, or there's a particular vulnerability in some firmware or some cryptographic ciphers that we are using, some implementation, for example, OpenSSL. How do we go about it? We coordinate as a community, and then we identify ways to upgrade, mitigate the issue to kind of like minimize the impact. And really, it's this cat and mouse game that we play with the attacker. Like this has always been the case. In the kind of like cybersecurity community, we have the whole idea of defense in depth, layered approach, Swiss cheese model. Relying your entire security on just one thing, be it like ZK or MPC, is just asking for trouble. It's always better, no matter how theoretically good it is, it's always better to have multiple layers of defense. And that is why that is the kind of like the golden rule in terms of the security community. So that's kind of like the first point I want to address. The second point really is about like what we do at Automata Network, or the main thing that we are focusing on is actually on machine trust, on the whole rule of trust. The idea that like just because I have a hardware rule of trust and therefore it's unreliable or untrustworthy, I think you're kind of like throwing the baby out of the bathwater. It can be exploited, but there is a level of difficulty involved in it, just like I explained. And the thing about it is, once we understand this, there's a lot of very interesting things that we can do with it. It's not just for TEE, it's not just for secure execution, it's not just for verifiable computing. The hardware root of trust actually allows us to do something very important called attestation. or to create this chain of provenance. Like, where is the source of my data? Who generated this data? Is this data generated from a ML model? Is it from a particular sensor on my Sony camera? Or is it generated from my iPhone that I'm using or an Android phone that I'm using? All this is especially important if you want to derive some sort of like trust relation in the world. And like from that point, kind of like from that angle, that's why we choose to really dive in and focus on the idea of extending this trust. How can we derive this trust? How can we extend this trust? How can we make it such that we can have a attestation network that is owned by everyone, a decentralized attestation mechanism? I think a lot of people actually forgot. Like, they think about attestation as like DCAP or EPID or AMD, kind of like attestation primitives that are designed by manufacturers. But back in the day, like 10 years ago, when I first started doing this, you have to design your own attestation primitive. And this is still possible. We can actually build attestation primitives on top of Intel SGX, on top of Intel TDX, on top of AMD SCV. And this is what we are doing. And I'm like very happy to kind of like talk more, but I'll kind of like end here so that we have more time to go into the more interesting discussion.
That was already super interesting. Thank you so much, ZL Zeng. It was amazing to have you here. And yeah, also everybody, please share your questions and whatever it is that you want to ask. You can use the chat. Thanks everybody for speaking. Thank you all for presenting your work about the current state of TE network. I think that really gave us a great insight. And I'm also aware that there's more to it. And we hope that in the upcoming sessions that we are planning to do, there will be even more space for more people presenting their work and their ideas. Yeah, while we are doing that, because I know that some of you already left some post-its there, does anyone feel like sharing anything they found particularly interesting in their rooms? Any feedback, any stories from your breakout rooms?
Seems like everyone is looking forward to having something stronger for the root of trust than just an untrusted hardware.
Yeah. Let's hope so. So MC is raising their hand, please.
Hey, yeah, Zoe from Fada here. I'm somehow not able to open the Miro board, doesn't load for me. So if you can just add me via email, that would be cool. But yeah, from our breakout room, we were for people was overall like positive perception about the topic, right? Everyone is eager to work on it, but we also saw, okay, besides of course detailed technical challenges, it's also a lot about like the organization, like how do we organize, orchestrate something like this, like what we are doing here today, right? How can we bring stakeholders together? How do we coordinate also with the manufacturers, right? Because doing like research and designing is like phase one, and then how can we actually implement and have these chips ready to use also, right? So it's a very, like, we are very aware of like the size of this, I would say even like an industry movement, which is super important because specifically for Web3, it will have an impact like the open source chips on level architecture levels, right? On level different use cases as well. We're not talking only about like the teams like Fala, Secret, Automator that use TEs, but even others for MPC or ZK and TE use cases. So me personally, I'm super excited, like what kind of impact it can do for the overall Web3 world and use cases. But in our room also, we discussed that we are aware of like the size of this movement, but the support and interest is there. And I think if we just continue, to find ways to orchestrate this with really all the important stakeholders, which, for example, also the manufacturers. I think also, I mean, I'm working closely with Silvan. I mean, we guys have also met Julio and Damla, like, to discuss how we can actually kickstart and fund this kind of movement, because the money, of course, is also very important. And I think a lot of teams that are here already might be interested also to say, hey, we get together with like brand support, right? And then we have also bigger investors and so on. But even like Fala specifically, we would love to support with like however we can, but this is a movement that we also need different financial sources for. So yeah, this is where we stand with Fala, and this was a little bit of what we discussed in our breakout room.
Yeah, thank you so much, Zoe. A question for everybody. What do you think? What would be a good format to keep this going? Like today was, we made a start. There are many things we can imagine, revolving hosts, or, you know, a question also about the format. Do you think that kind of format works well? If not, what could you imagine maybe to tweak? Do we need more time? I would be curious to hear from you.
I mean, I would have one idea. Again, I can't open the Miro board at the moment, but what I heard, Ela, that you said there are different areas like marketing, communications, tech, right? Like really like the different like departments also for this kind of project, that these breakout sessions or these recurring meetings can be also done for the specific group, right? For example, the people that are good in PR and communications, or even like strategy, how can we actually get this kind of alliance or like this movement going? Then like the engineers from the research side discuss more, so we can structure it a bit more in like these specific areas where the experts from these areas can discuss how to move things forward. And then of course, bringing all together in a specific room again as well.
Mm-hmm. Yeah, amazing. That of course could be a really nice outcome, to think of the different disciplines or areas that people want to focus on when building the network, and then making sure that those people can have regular meetups. I agree. Let me just quickly take a look at the Miro board and let's see what's going on. If there's anything you would like to comment on, you can just raise your hand, open the mic, or you can also comment in the chat if you don't want to speak up. I see there's stuff happening in the Miro board, which is great. And I also think some people still need time. So I want to tell you that take your time also after that meeting, right? You can still add to the Miro board after this meeting will be finished. I just want to make sure that for the last 10 minutes that we have in this call, that we really can get the best out of it. And yeah, the stage is yours. If you have any ideas on how to move forward with this network, any suggestions, please feel free. Raise your hands, open your mic, or use the chat.
Hi, this is Alex from Secret Labs. I'm sorry I joined late because I mixed up the times, but from what I understand, there are still strategically, like, there's several possible goals of this project. Like, it can be developing a whole new open source, like, full-size CPU architecture. It can be developing like a separate, maybe TE module that can be paired with existing mainstream hardware, or cooperating with manufacturers to convince them to somehow open source at least that part or everything, which is so to me, maybe it's worth defining or thinking first, like, which of those strategies is, or which are feasible at all. Maybe just one, maybe it's all three of them. And then see how we can allocate our resources towards those goals, right? Because we all understand that creating this whole piece of hardware, it's a big project, and it will require later on more significant partners, investors, and bigger things. So I think it's very important to define those strategic areas. It doesn't have to be one. Maybe it's all three. Maybe it's more. Or maybe it's less. But I think it will be good to define and then work then build some sort of a roadmap and work towards those goals. The roadmap may be technical, PR, business, whatever.
Thank you so much, Alex. I wonder what would be like a strategic way to moving forward? Would it be good to come up with, for instance, some scenarios that people can test and then use that as a basis for strategizing further? Or how could we concretely organize that in one of the coming sessions?
I think that we have researchers on board, people who understand hardware really well, and maybe we can build this group that can suggest different strategic approaches. Because some of the things I mentioned, maybe they don't even make sense, right? Because I'm not really deep into this. So I think this would be a good start. Just seeing all the possible options that can take us to this goal of open source verifiable TEs. Mm-hmm. And then we can have a discussion about how difficult or how easy each path is. None is easy, by the way, but how difficult they are, and then choose where to focus on, initially, and then later on, like kind of building kind of a roadmap, which can have branches, right? We can have parallel tracks, but I think this will help us really. So first, having the list of options, discussing them, choosing a subset, and then moving forward and mm-hmm. building like a roadmap for each one.
Mm-hmm. Yeah, that sounds really good. Anyone to comment on that? Julio says yes to. Julio, I think you have issues with your mic, right? You want to try again, or maybe no? Okay. No worries. Yes, to roadmap, Julio says. Any other comments to what Alex was just suggesting? Yeah, I think that really sounds like a good plan. And yeah, Sylvain, Julio says Sylvain has some ideas.
Yeah, I can talk a bit about this here. Obviously, like Alex pointed out, we're dealing with something that's fairly complex, right? And it can be approached from multiple angles. I'll instead of trying to give a super general overview or roadmap, I'll give one possible example that can then be used, that we can brainstorm around and shift things as much as we want. But so far in looking into this, because again, my background is also not hardware engineering, I think the key thing is for us like community interaction. So we need to blend more with the hardware research communities and the hardware industry. Because right now in the blockchain community, we're a user of a product, which is mainly IntelliJX, Intel TDX, and AMD SEV. And unlike anything else we do where we can modify the software and so on and play with it, here we're dealing with a bit like a black box in the sense we have to accept as though that it was just given to us and we cannot modify anything. So I think to move from that state to a state where we can have more experimentation happening, it's inevitable that we have to then work hand in hand with hardware researchers and the hardware industry. Now, to give a concrete example here, so in the context of the hardware research, somehow a bit by stroke of luck, I was put in touch a couple months ago. There's a group in Belgium, UC Louvain, Torben is part of, who's in this call, and they have a bit of a large organization called simplecrypto.org. I'll put in the chat, which they have this mission statement of building exactly what we want. Okay, so it's just like it's not something we don't need to create it. It's already there. It exists. So simplecrypto.org has a mission statement to build open source hardware that is secure against physical attacks. So this is already an example. Hey, we have to leverage this. It's there. We have to interact with these people. And when looking into this, there's actually a very active and deep hardware research communities that is, that is not being leveraged here in terms of what's possible. Because, okay, so one, right, working with simplecrypto.org is one example, okay? And to work with them, they have, some of you in this call have seen their proposal. They have a proposal to build signing oracle, which is basically to have a more secure root of trust that is secure against physical attacks. And that key building block is the most fundamental building block we need for more secure TEs. And on top of that and around that, we can then figure out how to build and extend it to have the TEs that we would eventually want. So there's a lot of work that can be done here to see how we can prepare the ground when we have eventually this building block, which could take 2 to 3 years. So that's just one concrete example here that I thought I could give. And just using that as a seed, I mean, there's a lot of work that there are lots of possibilities in terms of funding, in terms of education, also better understanding what's at work here, what are the limits, and will be these new security guarantees, and then also how can we have other teams mobilized who can then contribute work to integrate that work and to test it also. Yeah, if Torben wants to talk, he could explain more. Yeah, so that's the main thing I wanted to emphasize. But to just like close it with one sentence, we absolutely need to work hand in hand with hardware research and hardware industry communities, and the open source hardware movement too, which is also a vibrant movement. Yeah.
Thank you so much, Sylvain. And knowing that we are basically, it's 5:30, but nonetheless, for those who can stay on, we'd love to hear from Torben about Simple Crypto Fund, and please give us some more insights.
Yeah, hi everybody. So I did not prepare anything, but as Sylvain already introduced, we have at some point managed to like get together and write this proposal about like basically what I would call a first feasibility study of whether like the type of open source TEEs can be built that we have in mind. I mean, what we are mostly lacking is some funding for full-time engineers to work on this. So organization would be done in our group, and we have like the expertise and whatnot. What we don't have, because I'm an academic researcher, I have like research to do with like the main focus. So like these development projects, they eat a lot of time. So having a bunch of people who work on that 100% would be very helpful. And what we are aiming for then is really already a very important building block towards an open source TEE, which remains secure in the presence of physical adversaries. So you have side channel attacks, you have hardware chip attacks with FIPS and ZEMs and whatnot, fault attacks. And we're confident that we can build something which gives you basically a signing oracle for remote attestation, which remains secure in presence of these adversaries and in presence of this open source model. But this is something that requires a lot of work. It requires tape outs with some open source foundries where we are able to tape out chips where we can publish the details of, right? So this is something that some people don't know. If you build a chip and you get it taped out from like a commercial foundry, they have some intellectual property in your design because you're using some standard cells or whatever. So you're not allowed to publish stuff. So open source in the hardware world is also something which is quite more difficult than in the software world because it goes beyond just sharing code on GitHub. Yeah, I mean, we have written this proposal of 2 pages. Feel free to share it around and get in contact if this is something that you find interesting. We are anyway doing like the researchy stuff that is needed for this type of outcome over the next years. But I would say without this additional funding, having like a real prototype that we can test and play around with will hardly be feasible.
And yeah, I guess that was it for this first call, for this initial meeting with all of you. Thank you so much for being with us. Thanks a lot for your active contributions. And it was fun. And I find it quite impressive. I learned a lot from you. And yeah, have a good evening, a good day, wherever you are, and hope to see you again soon.
Thank you. Thank you for
Thank
organizing.
you.
Thank you so much,
Thank you
everyone.
very much. Hope for more of those, and it seems like a great initiative. Very excited.
Thank
Thanks,
you.
Frank.
You.
Bye bye.
Bye.